All right, welcome back to Mr. P Helps with Algebra. This is Unit 4, Topic 1, Lesson 1. We are going to be multiplying monomials times binomials. A monomial just means there's one part, so that's one number or one expression on the outside being multiplied by, there are two expressions. There's a 5x and there's a minus 4, so that we call that a binomial. If there's three parts, we call it a trinomial. And polynomials just means any amount of parts. So it could be one part, two parts, three parts, four parts. So anything that's more than three, we just simply call a polynomial. Even though technically a monomial is a polynomial, though. So you're going to use the distributive property, take whatever's on the outside, multiply by everything on the inside. 3 times 2x is 6x. 3 times 7 is 21. Bring that down. So whenever you're multiplying a number or a constant multiplied by this number right here, which happens to be have a coefficient in front of the variable. So you just multiply the constant times the coefficient, and that gives you the new expression. Negative 12 times 5x is negative 60x. And negative times a negative is a positive, and that's going to be 48. 5a times negative 3a is negative 15a. And 5a times 13 is 65a. But when you're multiplying a times another a, so what you're going to notice the difference about questions 3 and 4 than 1 and 2 is the fact that it has a variable on the outside of the parentheses. So when you have an a times another a, that's going to make a squared. Now I know you might be thinking a times a is 2a, but that's actually a plus a. When you add them, then so you have 1a plus another one, you just 1 plus 1 makes 2 a's. So this is negative 15a squared plus 65a. Once again, we have a variable on the outside being distributed on the inside, which also has the variable. So 9 times 6 is 54, x squared. 9x times negative 2 is negative 18x. Once again, just multiply the coefficient times the constant, like we talked about in the first question. All right, so this lesson is going to get us to analyze quadratic patterns. We're going to be talking about modeling quadratic patterns as well as quadratic equations. Looking at this pattern, we notice that the cell phone bar goes from 1 block to 3 blocks to 6 blocks to 10 blocks. So some of you might not recognize a pattern right away because when we've done arithmetic sequences, which are linear equations, it's always had a common difference, which means it's adding the same number each time. Or you've seen exponential functions, which are multiplying a geometric sequence, times 3 times 3 times 3. But this time it has what we call a second difference. It goes plus 2, plus 3, plus 4. So what's happening here is the numbers that are being added, the differences, are also increasing by 1. So it has a second difference because this is plus 1, plus 1, plus 1. Describe the pattern you see in the figures above. Okay, so that's how I describe it. It has a second difference of plus 1, which basically means that the numbers that are being added are increasing by 1. Assuming the pattern continues, draw the next figure in the sequence. Well, you could say that basically what's happening is they're adding another row or column here at the end that looks like that. Sorry about the announcements. Can't help that. How many blocks would be in figure 10? Figure 10, well, the next one's going to have 15. And the next one after that's going to be, so that's figure 5. Figure 6 is going to have 21. Figure 7 is going to have, let's see, that's plus 6, that's plus 7, makes 28. Figure 8 is going to be plus 8 from that, which makes 36. Figure 9 is going to be plus 9 from that, which is 45. And the 10th one's going to be 55. So 55, using the table I've just done, 55 is going to be how many blocks are in the 10th figure. Examine the sequence. So what you might have just noticed is that in order to get the 5th sequence, I added 5. To get the 6th sequence, I added 6. To get the 7th sequence, I added 7. So what's interesting here is that you're always adding whatever figure it is. And I'm going to use that to write a recursive formula. I know I don't have space down here. So I'm going to write, I've just put R for recursive and E for explicit. So for recursive formula, you always start off with some sort of starting point. So f sub 1 was 1. So that means the first figure had 1 block. And the f sub any number, which is n, is equal to its previous, which is f sub n minus 1. So let's say I'm trying to find the 100th figure. F sub n minus 1 represents the number of blocks in the 99th figure. It doesn't represent 99. It represents the amount of blocks in that figure. And then I'm going to add n to it, which will be 100 in that case. Just add 100 because it's the 100th term. So let me apply that to something you can see, the 5th term. So if I'm trying to find f sub n, which is the answer, we know it's 15. But you would take f sub n minus 1, which is 10. That's how many blocks are in the previous term. And you add n to it, which is 5, because that's what you're looking for. And that gives you 15. So there you go. So you can see that in action. Now, the explicit formula. Now, I probably have showed you a way of putting this into the calculator and having the calculator find the answer for you. So once you did that, you should have gotten y equals 1/2 x squared plus 1/2 x. I don't really have the ability here to show you what I did in the calculator. So when the keystrokes, when you press the graphic calculator, press that is going to be stat for statistics, and then go to edit, and then put your data in. You need at least 3 terms, so you can put 1, 1, 2, 3, 3, 6 in for y sub 1 and y sub 2. And then once you've done that, you go back to stats, go to calculate, I believe it's number 5 for calculating a quadratic regression, and then it'll tell you the formula that I've just provided you with. Okay, so I'm going to leave it at that. I will show you in the next lesson how to do it without a graphic calculator, which only works if you can find the pattern. So it's going to be a little bit difficult with this pattern because where's the half coming from? What does that represent? Doesn't really represent anything here. I probably could come up with another quadratic equation, but I'm going to leave it with just that for right now. So I'm going to skip the graphing for right now. You're going to notice that these are parabolas, which we'll get to that later on. So in each set of 3 functions, hey, one will be linear and one will be exponential. Video, yeah, that's all right. Hi, people. Video, this is what happens. One of the 3 will be new category of the function. List the characteristics in each that helped you identify the linear. So characteristics. So I'm looking at 128 to 256. That is adding 128. And then this is going to be adding 256. And then this is going to be adding, well, what you're noticing here is that numbers are really just multiplying by 2. So since it's a geometric pattern, then that tells us, since it's times 2, that this is an exponential equation. The explicit formula would be y equals starting point, which I'm going to just simply use the 7th term, which is 128 times the pattern of 2 to the x minus 7 pattern, because that's the 7th term. The recursive formula is just simply going to be the first term, or the 7th term is 128. And then to find any term, you just simply multiply it by 2. So f sub n is equal to f sub n minus 1, meaning the previous term. And that's multiplied by 2 because that is the pattern. All right, question B. So I'm looking for a pattern once again. 49 goes to 64, goes to 81, goes to 100, goes to 121. If you're really observant, you will notice that really the f of x, the answer is the x squared times itself. I could find the second difference, but I've already noticed that pattern. 7 times itself is 49, 8 times itself is 64. So the explicit formula is what we call the parent function of quadratics. It means the most basic form of possible. So it's just x squared. The characteristics I know is that the x is being multiplied by itself. And the recursive formula, so the recursive formula is really the difference. It's the linear pattern between the x's and the differences. So it looks like I do need to find a difference. 49 to 64 is an increase of 15. And then 64 to 81 is an increase of 17. No calculator here. So that's an increase of 19. So it looks like the second difference is plus 2. So that means, so we have 2 times x is 14 plus 1 would be 15. So it looks like it's 2x plus 1. And that works for all of them. 2 times 8 would be 16 plus 1 is 17. So it's simply just the previous number, f sub n minus 1, plus 2x plus 1. F sub n is equal to, and don't forget to give a starting point as well, f sub 7 is 49. Alright, I'm going to erase this. Yes, you're going to actually have to watch the video. You probably can't read some of my handwriting anyway. 13 goes to 15 is plus 2, plus 2, plus 2, plus 2. So that's a linear equation. It's plus 2. Explicit formula is going to be y equals 2 times x, because that's the pattern, and plus the starting point. So I'm going to do 2 times this x is 14, and notice that that's 1 less, so it must be 2x minus 1. And then last but not least, recursive formula, f of 7 is 13. That's my starting point. F sub n equals f sub n minus 1 plus 2. All right, so please give it a like to help you learn something, and follow if you haven't done so already. Please subscribe. Have a great day. Thanks for watching.